Welcome to all. I am Vipati CP. Here I am going to teach you the CHO 150 Basic Organic Chemistry course for MSc first year. Last time we learned about the syllabus regarded to the CHO 150 course. So let's start our topic. Our topic includes some reactive intermediates, ylides, some rearrangement reactions and oxidation and reduction reactions. Okay, so let's start with the reactive intermediates. Here these reactive intermediates which can be formed during the reactions which are mostly non-isolable, quickly converted and the more stable molecules. Okay, there are the different reactive mechanisms, that is carbocations, carbene, nitrene, some radicals, arine and the carbocations. These are some reactive mechanism or reactive intermediates. Okay, here first of all let me learn what is the reaction intermediates or reactive intermediates. These are the intermediates molecule entity like atoms, ion or the molecules with a lifetime appreciable longer than a molecular vibration that is formed directly or indirectly from the reactant and react further to give the products of a chemical reactions. That means these are the intermediate which force to the reactant to react and there's a formation of the product. The main carbon reactive intermediates are first carbocation. Here there are stability equivalents such as oxonium ions. Next is carbanion, then carbene, free radical, nitrene and the nitrinium ions. Let's we learn their structures. First, that is a carbocation. This is the, here you can see this is the carbocation charge intermediate which having a positively charged carbon, that is called as a carbocation. Here a 3R group which is attached to this carbon, there is a less valency, that's why it is a carbocation having a positive charge. Next is carbanion. Carbanion, that means the carbon which having lone pair with negatively charged ion, that is called as a carbanion. You can see here this is a carbanion. Okay, then next is what, the radical. Radical, that means the carbon having only one electron, that is called as a carbon radical. Okay, and the carbene. Carbene, that means the carbon having a lone pair of electron, that is called as a carbene. Here these are some structures of reactive intermediates. First, carbocation, that means carbon having a positive charge. Carbanion, that means carbon having a negative charge. Carbon radical, that means carbon having only one electron, and carbene, that means the carbon having a lone pair of electrons. Okay, so start our chapter with the carbocation. There are chemical species bearing a positive charge on a carbon and having a 6 electron in its valence shell are called as a carbocation or carbenium ion. Okay, here you can see the formation of the carbocation. This is the trimethyl chloride tributyl chloride, tertiary butyl chloride compound, or it is called as a trimethyl chloro uh, tertiary compound. Okay, tertiary butyl chloride compound. Here this, by removing of this chlorine like this, there's a, for their valency of this carbon is going to decreases and the carbon get a positive charge. By removing this chlorine, there's a formation of the carbocation. This carbocation is called as a tertiary butyl carbocation. What is the carbocation? The chemical species bearing a positive charge on the carbon and having a 6 electron in its valence shell are called as a carbocation. Okay. Here these are some examples of the formation of the carbocation. First, you can see here by the acylation reaction, the chlorine get removed and this carbon which get the positive charge, that is the carbocation here we form by the acylation process. This alkene which on addition reaction of the hydrogen, here the one hydrogen is attached to the carbon number 1 and this carbon number second is becomes a positively charged. This is also the one more carbocation. Next is what, here by the addition of the BF3 there is a formation of this intermediate hydronium ion, and by removing this hydronium ion there is a formation of this secondary carbocation. Okay, these are some examples of the formation of the carbocation. Simply, what is the carbocation? Any carbon having a positive charge, that is called as a carbocation. Here this carbocation which is positively charged carbon, which is divided into the two types. First, that is what, the trivalent positive species, or this is called as a carbanion ion. For example, CH3 plus C2H5, these are the carbocation, and the carbonium ion, these are what, the pentavalent positive species. There are two types of carbocation. The first, that is a carbonium ion. Here the carbonium ions are the carbon which is trivalent positive species, the like CH3, that means 3 hydrogen attached to the carbon, that is trivalent, and carbonium ion, that means the pentavalent positive species. These are the non-classical carbocations. Okay. Next is what, the carbocation. Here we learn some examples of the carbocations. Here you can see in this picture, yes, you can see in this picture, these are the allylic carbocation, that means the double bond is attached to the CH2 group, this carbon having a positive, that is called as a allylic carbocation. The carbocation is attached to the benzyl, that is called as a benzylic carbocation. Here we learn the stability of the carbocation. That means here what happened, these benzylic are the more stable than the allylic cation. Why? Because more the canonical form, more is the stability. That means here in the benzene ring there are the more canonical structure or resonating structure like this. This double bond which can be shifted from one position to the another position. Their canonical structure is going to increase. As the canonical structure is going to increase, or unsaturation is increased, their stability is going to increase. That's why the benzylic carbocation is more stable than the allylic carbocation. Okay. Next, here this cyclopropanyl methyl cation are even more stable. This is also more stable than the benzylic carbocation. Okay. And here these are some another example, that is carbonyl carbocation and 7 carbonyl carbocation are the non-classical example of the carbocations. Okay, these also having a stable structure of carbocations. Okay, you know just the structure of this carbocation and their stability. Both of these are a stable carbocation. Okay, and here most important is what, as the canonical structure is increases, their stability of carbocation is going to increases, and that's why here benzylic carbocation is more stable than the allylic carbocation, and cyclopropanyl methyl cation is more stable than the benzylic carbocation. Okay, why? Because this is a this is here why this happen, because here in this case this is a secondary tertiary carbocation, this is a tertiary carbocation, and this benzylic carbocation is a primary carbocation. You know very well what is the primary carbocation, secondary carbocation, you learn in a 12th class also. Okay, Here the tertiary carbocation is more stable than the primary. That's why here the cyclopropenyl methyl cation are the more stable than the benzylic carbocation. Let's we learn there the stability of the carbocation. Here the alkyl group tends to stabilize the positive charge on the sp2 carbon of the carbocation. That means here when 3R group is attached to the carbon, sorry, here that time what happened here, there is a tertiary, that carbon is called as a tertiary carbocation. Whenever 2R group is attached to carbon, that is called as the secondary carbocation, and only 1R group is attached to the carbon, that is called as a primary carbocation. Okay, and here the CH3 group having positive charge, that is called as a methyl cation. Okay, as the R group is increases, there increase in stability of the carbocation. You can see in this picture here the methyl cation is a least stable than a primary carbocation. Primary carbocation only R group is attached. Here from left to right, sorry, right to left, here what happened, their R group is going to increase. Here there is a 0R group in this case, then 1R group, this is just 2R group is there, and here there is a 3R group is present. That means as the R group or alkyl group is increases, these R tends to stabilize a positive charge on the carbon, sp2 carbon, and therefore their stability is increases. Okay, from right to left. Okay, this is very important for the examination point of view. Okay, the stability of carbocation is increases from methyl cation to primary carbocation, primary carbocation to secondary carbocation, and secondary carbocation to the tertiary carbocation. Okay, next is the stability of the carbocation of the different hybridized carbon. That means what here, in this case the carbocation are destabilized as hybridization goes on sp3 to to sorry sp3 to sp. That means here the sp3 carbon is a more stable carbon than sp2, and the sp2 is more stable than the sp. That means sp carbocation is a least stable carbocation. This is destabilized by the pi bonding. Okay, and here the most stable carbocation is sp3 carbocation. Okay, and here think of this as the opposite of the effect of hybridization of the carbanion. If there is a carbanion is there, that time what happen, here the least stable is the tertiary carbanion. If we compare it with the carbocation, that is C plus or C minus, this is a carbanion. This is totally opposite to the carbanion. Carbanion, that means what, the carbon having a negative charge. If you find out the stability of the carbanion, that time here the tertiary or sp3 carbon or sp3 carbanion is the least stable carbanion, and sp carbanion is the most stable carbanion. In case of what, carbanion, this is for carbanion. Okay, and this is for carbocation. sp3 carbocation is the most stable carbocation, then sp2, and then sp carbocation. Okay, this is about the stability of the carbocation. Let's we learn the hybridization of the carbocation. Sorry, it's my mistake, the spelling of hybridization is a hy. Okay, hybridization. Okay, here HYBRIDIZAION. Okay, the hybridization of carbocation. Carbocation, that means CH3 plus carbocation has a sp2 hybridization. Let's we see how it shows sp2 hybridization. Okay, okay, sp2 hybridization. Here this we has to find out the hybridization of CH3 plus, sorry, Here we learn the hybridization of CH3 plus. That means the central atom is what? Carbon. Okay, and the carbon having the positive charge. Okay, the what is the valence electronic configuration of the carbon? It is 2s2 and 2p2. Okay, then the carbon which having a positive charge, that means one electron is removed from the carbon. That means the C plus ion having valence electronic configuration is 2s2 2p1. We fill the electron in the shell that like this manner, 2s2 and 2p1. Here this one electron of the carbon, this is the one unpaired electron of the carbon, which is what? Hybridized with one hydrogen. Okay, this is the ground state. This one is the ground state of hybridization. In the excited state, what happened here? This electron of the 2s is excited to 2p. Okay, and there is a formation of what? One s orbital and 2p orbital having a only one electron. Okay, and the combination of this hybrid orbital, there is a formation of what? 3 sp2 hybrid orbital. What happened here? Here we learn the carbocation, hybridization of the carbocation. Here this carbon having valence electronic configuration 2s to 2p2, but this carbon which is the carbocation, that means carbon having a positive charge, that's why their valence ground state valence electronic configuration is 2s2p1. Okay, then this carbon get excited state, then what happened? This one electron from the 2s orbital is excited to the 2p orbital, and there is a formation of what? The hybrid orbital. Okay, this is the hybridized state. This state, then the combination of 1s and 2p, there is a formation of what? sp2 hybrid orbital. Okay, since only 3 electrons of the carbon atom are participated in the hybridization orbital formation, it form a sp2 hybridization which contain one electron from two hydrogen atom, and therefore there is a formation of what? Trigonal structure. Let we learn the hybrid orbital is what? sp2 hybrid orbital. The hybridization is what? sp2 hybridization. Let's we learn their structure of the carbocation. Here you can see here what happened. This sp2 carbon, the sp2 hybrid orbital which is combined with the one electron of the hydrogen, and there is a only 3 unpaired electron present in the carbon, that's why only 3 hydrogen is attached to this carbon, and there is a formation of the trigonal structure. This is what? The trigonal. sp2 hybridization always shows what? The geometry trigonal. Okay, and here you can see the vacant position. There is a one vacant p orbital is there, and this is the vacant p orbital, and this shows what? sp2 hybridization. This is about the hybridization of the carbocation. Always ask in your examination, explain the hybridization of the carbocation. Okay, then you have to solve like this manner. You have to find out the hybridization, their excited state, ground state and a hybrid state. Then you have to write down their structure and their vacant p orbital. The carbocation also, the carbonium ion or carbonium ion is a positively charged carbon. They shows the sp2 hybridized with the vacant p orbital. Okay, next here this is about all the carbocations. Next we will going to learn the carbanion ion. Thanks for watching this lecture. Please subscribe this channel for getting a new excited lectures related to this syllabus, and don't forget comment as writing your name, and if present you have to write out your roll number. Thank you very much.